Welcome back to the deep dive. We spend a massive amount of time looking at the shiny side of technology.
All the time. We're talking neural networks, quantum computing.
Exactly, the stuff that makes headlines. But if you actually sit down with the people who build systems that last, the senior engineers, the architects, they rarely talk about the flash. They talk about the plumbing.
That's so true. The unsexy critical infrastructure,
Yeah.
the pipes behind the walls.
Right. And today we're going to talk about software plumbing in one of the most, let's say, notoriously academic languages out there.
Haskell.
Haskell. Just saying the name makes some developers sweat.
It really does. It has this reputation, for being an ivory tower language. You think Haskell, you think monads, category theory, code that looks like calculus.
But that's not what we're looking at today.
No. We're looking at a source that strips all that away. We're diving into the engineering journal of a developer named Ang, specifically part 52 of his notes on Haskell programming. And what I love about Ang's approach is that he calls himself an old software plumber. He isn't trying to impress you with his IQ. He's just working on a real project.
A console app called XS2 ebook.
Right, a tool to convert files.
Oh.
And he's just trying to make the code readable. He's figuring out the best way to move data from point A to point B without making a complete mess.
And that's our mission today. We are going to bypass the intimidation factor. We are not going to talk about advanced math. We're going to look at a very human problem that every programmer faces.
Regardless of the language.
I have a data object, and I need to get a piece of information out of it.
It sounds so simple.
It should be simple. But as we'll see in Haskell, the history of doing that simple thing is, well, it's complicated. We're going to trace how Ang refactors his code from the old school way to using some very modern and maybe controversial extensions.
We're basically watching a plumber decide between using old copper pipes or modern PEX tubing and explaining why it actually matters.
I love that. Okay, let's get into the code. Ang starts by refactoring the main entry point. And right off the bat, line 1, he triggers a debate. He writes .module main where. Now, to me, that looks incredibly redundant. The file is main.hs. It has a main function. Why do we need to explicitly tell the compiler that? Doesn't it know?
Oh, the compiler absolutely knows that. If you deleted that line, the code would run perfectly fine.
So it's just extra typing.
No, this isn't about making the compiler happy. It's about what Ang calls coding discipline.
Discipline, okay.
Think of it like this. If you're writing a quick script, you don't care what's public or private. But Ang is building an application. When you write module main, where you are creating a contract.
A contract.
You're saying, I don't care how many helper functions or secret variables are in this file. The only thing the outside world is allowed to touch is the main function.
So it's about containment.
Precisely.
Yeah.
It prevents what's called namespace pollution. Imagine you have a little helper function in there called helper. If you don't restrict your exports and someone else imports your module, suddenly their code can see your helper. And if they also have a function called help.
Oh, collision, right. Then you spend hours debugging why your function is doing something weird, only to realize it's running the wrong one.
Exactly. So this redundancy is actually a SACI feature. It's a good habit.
Okay, that makes sense. Moving on, we hit the imports. And this is where Haskell starts to look a bit alien. He writes, import xs2ebook.cli arcsire. Parse CLI. I want to focus on that argos part. The double dot, what is that?
The double dot is the all-access pass.
Unpack that for me.
So args is a data type. Think of it like a class in Java or a struct. It's a blueprint.
Got it.
Inside that blueprint, you have constructors, which build the object, and fields, which are the actual data, like input path.
Okay.
In Haskell, you can import the type without importing the ability to look inside it. If you just wrote args, without the dots, you could pass an args object around, but you couldn't see what's inside.
That seems weirdly restrictive. Why would you want a sealed box?
Encapsulation. If I'm writing a library, maybe I don't want you messing with the internals. I give you the car, but I weld the hood shut.
Right, so I can drive it, but I can't mess with the spark plugs.
Exactly. But here, Ang is the plumber. He needs to get inside the pipes. So the cat tells the compiler, give me the type, but also give me all the constructors and all the fields. Open the hood.
So without those two little dots, the rest of his code just wouldn't work. The data fields would be invisible.
Completely. It would be a compile error saying, I have no idea what input path is.
Okay, so we've unlocked the door. Now we get to the logic. He uses this operator, the left pointing arrow. We've touched on this before, but it trips everyone up.
Right. This is where we have to talk about the I/O context.
The dirty envelope analogy.
Let's use that. It's a good one. You see, In Haskell, functions are supposed to be pure. 2 plus 2 is always 4. It never crashes.
Mm-hmm.
But reading command line arguments, that involves the real world.
And the real world is messy.
The real world is very messy. The user might type garbage. The file might not exist. So Haskell wraps that result in an IO wrapper. Parse CLI doesn't give you an args object, it gives you an IO args object.
It's an args object trapped inside a bubble of real-world risk.
Perfect analogy. And you can't just reach in. The OG operator is the tool that pierces that bubble. It runs the messy action and extracts the pure args object so you can work with it.
So whenever you see that back arrow, you should just think, we are extracting a pure value from a side effect wrapper.
That is the perfect mental model. You're opening the dirty envelope to get the clean letter inside.
All right, we have our result. Now we move to the line of code Aang really focuses on. It's a print statement. Puts trln $processing.txt file name plus input path result, and there it is. The character that scares beginners more than any other, the $sign.
Ah, yes. The function application operator.
It sounds so formal, but Aang says if he deletes that one character, the program crashes. A build crash. Why?
It all comes down to precedence, or, who goes first.
Walk us through the failure. I delete the $sign. What does the compiler see?
So Haskell reads left to right, and it's greedy. It wants to eat arguments as fast as possible. Without the $sign, it sees, put strln, the print command. Then it sees the string processing. It immediately thinks, okay, I need to print that specific string.
Which seems logical enough.
It does. But then right after that string, it sees plus tac, the glue operator, for sticking strings together. So the compiler tries to glue the result of the print command to the next string.
And the print command doesn't return a string.
Exactly. It returns an action basically saying, I did it. You can't glue an action to a string. It's a type mismatch. It's like trying to add the color blue to the number 7. It makes no sense.
So the $sign fixes this how?
The $sign is a wall. It has the lowest precedence in the language. It tells the compiler, stop, do not evaluate the left side yet. Do everything to the right of me first.
So it forces the compiler to do the string gluing first.
Right. It says glue processing to the input path. Get that final single string, then and only then pass that whole thing over the wall to put strln.
So it's really just a way to avoid writing a ton of parentheses.
It is. You could wrap the whole right side in brackets, but then you get what they call parentheses hell. You end up with 10 closing brackets at the end of a line. The $sign just cleans it all up.
Aang also mentions a quick debugging trick here using show results.
Yeah, that's your rep from Python or ToString from Java. It's essential for plumbing. You need to see if water is actually flowing through the pipes.
Okay, so the water is flowing. We have the args record. Now we get to the core of this whole thing, the quest for readability. The problem is simple. We have the args object. We want the input path string inside it. Aang outlines 3 ways to do this, and honestly, this really explains why people find Haskell frustrating.
It really highlights the tension between mathematical purity and developer, ergonomics.
Method 1, the standard function approach. Aang writes input path result.
This is the default in Haskell. And it is the one that completely breaks the brain of anyone coming from, say, C# or Java.
Because in those languages, you'd write result.inputPath. The object comes first.
Right. Subject, def, verb. The object is the noun. But in classic Haskell, the field input path isn't just a label. It is a global function.
Yeah.
A getter. So you have to pass the object into the function.
So it's verb subject, get input path of result.
It's pure, but it has a massive downside. It clutters the global namespace. If you have 2 different records, a user record and a product record, and they both have a field named id, you're in trouble.
Because you'd have 2 global functions named id.
Exactly. The compiler can't tell which one you mean. So you end up naming your fields weird things like user-id and producted just to avoid collisions. It feels clunky.
It feels like coding in the 80s. Okay, so Aang moves to method 2, pattern matching.
This is very, very Haskell. He compares it to Elixir.
The syntax is args. Input path args.
This is destructuring. You're not asking for a value, you're describing the shape of the data. You're saying, I know args is a record. Reach inside, find the field labeled input path, and assign its value to a new variable called path.
It's very explicit.
It is, and that's record pattern matching. He also mentions positional pattern matching, which looks like args path is args.
That's a lot shorter. Why not just use that?
Danger. High voltage. Positional matching relies entirely on the order of the fields as they're defined.
Oh, I see where this is going.
If args has only one field, it works. But tomorrow, you add an output format field. Now args has 2 fields.
And your positional match only expects 1.
Boom. Compilation error. Or worse, the true nightmare if you have 2 string fields and you just swap their order in the definition.
Your code might still compile, but now you're putting the output file name into the input variable.
Silent failure. The plumber's nightmare.
So record pattern matching is safer, but it's verbose. You have to dismantle the entire car just to check the oil.
That's a great way to put it. Do you really want to take the engine apart every time you check the dipstick?
Which brings us to the climax, the modern stuff.
Yeah.
Aang talks about language extensions.
Right. Haskell evolves via these extensions. You put a little flag at the top of your file, and suddenly the compiler learns new tricks. It's like downloading a DLC pack for your programming language.
And the first DLC he enables is OverloadedRecordDot.
This is the one the community fought over for years.
Where the syntax is args.inputPath.
Just let that sink in for a second.
It looks exactly like Python or Java or TypeScript.
And that is a radical shift for Haskell. For decades, dot notation was seen as this sort of object-oriented heresy. But OverloadedRecordDot lets you do it.
Aang seems to love it. He says it offers better readability.
It lowers the cognitive load. You just use the dot. It reads left to right, object.field. It just flows.
But, there's always a but. He introduces a competitor, the other extension, record wildcards.
The magic syntax.
The code looks like this. Args. There are those double dots again.
Yes, this is the nuclear option. This line says, take the args record, open it up, take every single field inside it, and just dump them into the current scope as variables.
Whoa. So if args has input path, output path, author,
Yeah.
suddenly I have variables with those names just floating around.
Instantly. Without you ever typing their names, they just appear.
Aang compares this to something called register globals in PHP, and he calls it a nightmare. Now, I remember that, and it sounds terrifying.
It is a notorious security disaster. In old PHP, if you have that on and someone sent a web request to your site with .admin true in the URL.
The script would just create a variable called admin and set it to true.
Yes. And if your code used that variable to check permissions, congratulations, you've just been hacked.
That's insane. So is Aang saying record wildcards is just as dangerous?
No. And this is the critical difference. Haskell is immutable.
Right, meaning?
In PHP, those injected variables could change the state of the program. In Haskell, once a variable is defined, it cannot change. Record wildcards might clutter your code. It might make it confusing where a variable came from, but a hacker can't use it to change the state of your application because the state is locked down.
So it's safe from hackers, but maybe not safe from a confused developer.
Exactly. It's safe, but is it wise? And Aang's verdict is clear. He prefers the dot notation.
Because explicitness wins over magic.
Think about reading the code. With record wildcards, you see a variable named timeout. It's not defined anywhere. It's not an argument. You have to scan up, find that args line, then go check the definition of args in another file to realize, oh, it must be a field that got magically expanded.
It breaks your flow. You have to be a detective to figure out where your data came from.
Whereas with args.timeout, you know exactly where it came from. It's right there, from args.
It's interesting that an old software plumber prefers the modern syntax that mimics Python rather than the magical Haskell native way.
I think it shows wisdom. When you've been plumbing for a long time, you stop caring about being clever. You care about clarity. You want to look at the pipes and know exactly which way the water is flowing.
So let's recap this journey. We started with the discipline of defining our module to prevent leaks. We used the double dots to get inside our types. We used the $sign to avoid parentheses hell.
And we moved from that clunky, backwards function approach, past the verbose pattern matching, and landed on modern dot notation.
Which gives you the ergonomics of a language like Python, but with the safety of Haskell?
That's the idea, yes. It's a language growing up, realizing that being mathematically pure doesn't mean you have to be painful to use.
You know, this brings up something I've been thinking about. Aang chooses dot notation because he wants a human to be able to read and understand it. Explicitness wins.
Right. Code is read more often than it's written. It's the golden rule.
But here's a thought to leave you with. We're in 2026. Aang is writing this code, but increasingly, AI is writing our code, and AI is reading our code, and AI doesn't get confused by magic.
That's true. An LLM knows exactly where that timeout variable came from in a wildcard expansion. It can parse the entire project in a microsecond. It doesn't need the explicit dot to follow the trail.
So, does human readability still matter as much as it used to? Or will we see a return to these magical, implicit, dense coding styles like record wildcards simply because we aren't the ones reading it anymore?
If the AI is the plumber, maybe the pipes can be as complex as they need to be. But as long as there is an old software plumber, like Ang, trying to fix a leak on a Saturday night, I think he's going to want that dot notation. He's going to want to know where the water is coming from.
I think you're right. Until the machines take over completely, I'll take the dot notation too. That's it for this deep dive into the plumbing of Haskell. Thanks for unpacking it with us.
Always a pleasure.
We'll see you next time. Keep those pipes clean.